So for the first query, the key part is the order by class. I list last name first and then first name. So the reason is the circle doesn't sort data by default. Without this class, the names will show up in whatever order they happen to be inserted. Once adding it, makes sure the output is alphabetized and easy to read. For this query, I was thinking about what HR and the front desk need. Because they rely on a clean and organized directory, so they can look up phone number quickly. So sorting everything alphabetically by last name can making sure they can find anyone in a few seconds instead of digging through a jumbled list. And the second one, I used the union operator here because I needed to combine two sets of data that follow different logic rules. The first query postcards that expired in 2007 and targets them one way, and the second post that expired in 2008 and tags them differently. Union stacks those two result sets into one clean and uniform table. In this case, I can help the financial risk control team to prioritize their workload instead of dumping one giant list of expired cards on them. So I use union to group things clearly. That way they can get a neat to-do list, handle the 2007 expansions first, and treat the 2008 ones as follow-up tasks. It's all about making their workflow more efficient. So for the reason for using count distinct is that a lot of addresses can fall under the same city, and a regular count would just give you a total number of addresses, but adding distinct forces the table base to ignore duplicates and only count unique city names. So the query was designed for the operations director because they don't need to every individual street address. What they want is a high-level metric. By counting the distinct cities, and I give them a solid number that represent our overall market reach and geographic footprint. The logic here depends on the group by class. Since we are using the aggregate function AVG to calculate exchange rates, so we have to group the results by two currency code. That tells the database to split the data into separate buckets based on currency type, and then calculate the average for each bucket independently. So for the international sales team, daily exchange rate swings are too noisy. So by using AVG here, I'm smoothing out the data. It gives them a stable baseline rate for each currency, so which is crucial when they are setting product price for the next quarter. I used an inner join here because I only want the overlap between the two tables. An inner join filters out any rows that don't match. So the final output only includes contacts who who definitely have payment information on file. And the marketing team wants to run a promotion, but they don't want to waste time and money to targeting people who aren't able to make a purchase. So by using an inner join between the contacts and credit card table, I filtered out the just browsing customer and generated a list of people with verified purchasing ability, the one who can actually place an order right away. Number 6, the query combines aggregation with sorting. Um, After grouping by card type and counting the result, I use order by total cost desk. The reason is to instantly highlight which card types are the most common and to show the distribution from highest to lowest. This is really used for the strategic partnership team because by counting and grouping the different credit card types, we can see exactly which card our customer prefer. So for example, if the number of Visa card is huge, that tells us we should approach the issue and negotiate for better transaction fees. A multi-table join is necessarily here because the data is normalized. A person's name lives in a contact table, but the card details are in the credit card. So the contract credit card link table acts as a bridge connecting table A to B, then B to C, so we can pull columns from all three at the same time. This setup is made for customer service reps when they are on the phone handling billing issues. They shouldn't have to flip between three different screens by joining all three tables. So I create a unified view that puts the customer's name and the card details together in one place. So it can saving their time and hustle. Here I used a having clause instead of where, and that difference really matters. The where filters rows before grouping, while having filters group after the aggregation. So since the condition is based on max end of day rate, it has to be done with having. I was thinking about the risk control team's needs, specifically keep an eye on expensive currencies. So by filtering after the aggregation with having, I cut out all the low value currencies and flagged only the ones whose exchange rate spent about above 1.0. That helps highlight potential cost red flag. This query is built using a subquery structure. The logic flows from the inside out. The innermost query finds the ID for the Visa card, and the middle query grabs the related records, and the outer query finally puts the names. Let's see, we just launched a co-branded campaign with Vista, and I use a subquery here to isolate the exact IDs of people who hold the card. Then pass that list up to the outer query. This gives the promotions team a clear, highly targeted email list so they can send the customized offers. To look for missing data, an inner join wouldn't work because it hides no matching rows. That's why I use the left join to keep all the contracts from the left table, and then let me check for external values on the right table. This pattern is specifically meant to find rows that exist in the left table but have no corresponding match in the right one. So for the sales retention team, I wanted to identify users who might be sleeping away, by using a left join and checking for news. I can spot contacts and who are in the system but haven't added any payment method yet, so sales can follow up with them and close the deal.